Hey everybody, it's Miss Moran. This is our 308 video on using your calculator and the change of base formula. So this is going to allow us to evaluate logs in our calculator in many different situations, including graphing. So let's go ahead and take a look. Okay, for the first one, you can do this on a scientific calculator or your graphing calculator, is the log button and the ln button. Now our log, remember, is the common log, and our common log is a log with a base of 10 that we don't necessarily need to write because it's common. It's unnecessary for us to write the 10. It's just a notation in mathematics that's known to everybody. Whereas our ln is our natural log, and that is a log with a base of e. And again, we don't write that, we write ln of a. And that's assumed. Okay, so these buttons are located off to the left side on your graphing calculator next to the 7 and the 4. And if you want to just go ahead, we can just start typing some buttons in. Let's take a look. If we just type in log of 142, and let's round these to 4 decimal places. So we're going to do 4 decimal places. Okay, so this would be 2.1523. We'll do log of 1,000, which is 3. Now, if you consider the fact that log base 10, which is what this represents, of 1,000, this 3 should not be surprising. So keeping with our rounding to 4 decimal places, I would put 4 zeros there. Now let's do the next one, the log of 20. Negative 20, excuse me, and I end up getting a non-real answer as my error, and that is to take into consideration that by definition of log, we cannot have a negative value right there. So this one does not exist, or it's undefined on the real number system. All right, so let's try the natural log. So we're going to, once again, you're just going to type in the natural log, so ln of 25.6, and you get 3.2426. I was looking at my calculator, sorry, and let's try the next one, the natural log of 0.0452. And that gives me a negative answer, negative 3.0967 to 4 decimal places. And finally, we'll try the natural log, and the E button is, remember, it's the second natural log of 3. And that answer is 3. So we find another unique situation here. And I'm going to rewrite it like this. If I have log base E of E to the 3rd power, our answer comes out to just be 3. So you can even try that with a few others. E to the 4th power, we would get 4. Okay, and we can explore more about why that works together. All right, the change of base theorem. So this is a way to do things when the base is not E or the base is not 10. So our change of base theorem says that if I have log base A of x, that I have log of x divided by log of a, or the natural log of x divided by the natural log of a. This is called the change of base theorem, and it allows us to evaluate different logs of different bases. So please note that the x part goes to the numerator and the a part, or the base, goes to the bottom. And that might help you remember. Now, you don't have to type log over log or natural log over natural log. You don't have to do them both, but you do have to do one of them. Some of you may have found another way to enter this into your calculators. If you have the new operating system, there is another way. I'm going to instruct everybody because this works for everyone. So if you have the other operating system, you are more than welcome to use it. And we can discuss it in class, or you can work with some of your peers. But we're going to go ahead and do it the way that every calculator works, including scientific calculators. So this would be evaluated as the log of 17 over the log of 5. We would get exactly the same answer if we use the natural log of 17 over the natural log of 5. And again, as long as you're using the same log with the same base, it would work. So let's try that. Log of 17, make sure you close your parentheses, divided by the log of 5. And I get 1.7604 to rounding to 4 decimal places. I could try that again using the natural log just to verify that it is the same thing. And that once again gives me 1.7604. Okay, so let's try the next one. I'm going to do log of 0.1 divided by the log of 2. Or I could do the natural log of 0.1 divided by the natural log of 2. So log of 0.1 divided by the log of 2. And I get negative 3.3219. Okay. All right, now to look at the graphing of and how we can use change of base to help us graph. So previously, we would have taken this function, we would have identified that it moved to the right 2 spaces, and that we had a vertical asymptote at x equals positive 2, so we would have known that, so we would have had this asymptote here. And then we would have chosen some y values to create this log graph that we would have right along here. And we would choose those and create a table and plot the points. Well, now we can use our change of base. So let's go ahead to our y equals, okay, and clear anything else that you might have had out from your y equals, and let's enter using change of base. This would be log of x minus 2 divided by the log of 3. You can also use the natural log. Make sure you close your parentheses on that. So it would be log of x minus 2, close them, divided by the log of 3. Now, it's going to go ahead and just take a look at the picture before we look at the table, and I can see that it kind of looks like it stops, like it just pauses there, and that's because as it approaches this asymptote, the calculator doesn't have the right pixelization to really show that it's getting very close there. So what we have to imagine is, even though it doesn't show it, it really does continue down to infinity, and we must include that arrow on our graph. Okay, so let's go to the table of values. And as I can see, let's go towards the asymptote, and I notice that everything below 2 or below 3 doesn't work. So I'm going to look at my y values here using the calculator, and I'm going to start at positive 3. Oops, positive 3 is here, I'm sorry, and we get a 0 because that's my intercept. Okay, and then I'm going to have 4, and 4 doesn't really give us the most pleasant number, so how about 1? And that gives us a 5 over here, and then I'm going to scroll down, and my next nice number is going to come when I get to 11, comma 2. So these are some nice points that we can plot, and of course I can plot the other ones, they're just not as pretty. And then 11, comma 2. So this is my picture. And it does continue down close to that asymptote. So keeping this in mind, we're going to work more on graphing these using our change of base now that we have a way to enter it into the calculator. And I know that some of you again have found with the other operating system have used the new feature that my old calculator doesn't have, and you're more than welcome to use that. You have to know how to use your calculator. That's very important. So whichever one you're going to use, become familiar, use it frequently so that you are very confident when you approach an assessment. Okay, so I've got a couple problems here for you to try on your own on page 439. A couple of them will be sketching graphs using change of base. Make sure you check your answers in the back of the book. I've supplied mostly odd problems, so check those out. And then the even ones, of course, we can address those together. There's also an entrance slip on Schoology, and just make sure that by the time you finish this assignment that you were able to use your calculator to evaluate logs of any base, either the natural log, the common log, or also using our change of base formula. All right, thank you.